Hello friends, today I am now going to discuss problem on rotation operator in case of quantum mechanics. Today we will discuss the application of rotation operator in quantum mechanics. Actually it has huge and lots of application in the field of quantum mechanics. Whenever I will discuss the problem, you will understand it. First of all, what is a mathematical form of rotation operator? Mathematical form of rotation operator is exponential plus minus I sigma in theta, okay, equals, I will explain all the term when I will discuss the problem. Actually what I am aiming to do that you will understand all the expression of this mathematical expression, not only by theory. You can understand it by actual problem also, because problem is very important to solve. So what is the expression of this rotation operator? I cos theta plus minus iota sigma and sin theta, where sigma is what? Where sigma is Pauli matrix. Sigma n is Pauli matrices. Okay. So let's discuss a problem. First, let us discuss a problem. Then you will understand why it is so important, the rotation operator. So what is the problem is actually, the problem is if the direction with respect to I am reading what actually the question, because I know that handwriting is not so good to read. So let's read with me. The problem is if the direction with respect to right-handed Cartesian coordinate system of k vector z plus, I will explain what it means actually. K vector z plus is 0, 0, 1. Okay. The direction with respect to right-handed Cartesian coordinate system of k vector z plus is 0, 0, 1. Then the direction of k vector on application of e to the power minus I sigma z pi by 2, e to the power I sigma I pi by 4, I sigma I pi by 4. What will be the direction after applying this rotation operator? After applying this rotation operator, what you will get? After applying on this system and this rotation operator, what you will get? So let's discuss it. Actually, this k vector z plus is what? This k vector z plus is the eigenvector of the spin matrix Sz. Okay. Actually, 0, 0, 1 is a Cartesian form of k vector z plus, and in general, z plus is a spin z matrix. Eigenvector of the spin z is z matrix for spin half. Okay, let's discuss. Then we will discuss more lot about it. Let's discuss it. First, in the Cartesian system, let me change the pen color. In Cartesian system, whenever eigenvector will be represented, in Cartesian system, eigenvector is represented as z plus is represented as 0, 0, 1. Okay, but what its actual form is? Actually, it is the k vector of Sz matrix, Sz spin half matrix. Okay, it is a k vector of Sz, a spin half matrix, S equals half matrix. So spin Sz has eigenvector. What is the eigenvector of z plus? And positive direction means Sz has two eigenvalues, plus h cut by 2. Okay, and sorry, pen is not actually working. Plus h cut by 2 and minus h cut by 2. Sz has two values, plus h cut by 2, minus h cut by 2. And corresponding to plus h cut by 2, the eigenvector will be what? Corresponding to plus h cut by 2, eigenvector will be 1, 0. And corresponding to minus h cut by 2, eigenvector will be 0, 1. So in this case, they have mentioned the Cartesian form of z plus. It's very rare. It's actually just PIQ actually. Just PIQ. Okay. Here z plus means actually eigenvector of Sz spin half matrix And what they are asking if we apply that rotation operator on this SZ matrix, they have given the proper rotation matrix, proper rotation operator on it, then on the SZ component of positive means eigenvector 1 0. Okay. If we apply the rotation operator on 1 0, what we will get? And what we have to apply? What are the what are the rotation operator? Rotation operator we will apply, that is exponential minus sigma z. Let me write clearly. Exponential minus iota sigma z pi by 2 into exponential plus iota sigma y pi by 4. Now here it will come the application of rotation operator. Now I will discuss in detail what does it mean, the rotation operator. Actually what it means, rotation operator, exponential plus minus iota sigma n theta, what it mean actually. So let's discuss it. So rotation operator is what? Suppose rotation are two types. We'll discuss this problem, but before that I will discuss little bit theory about it, then we will again return to that problem. Okay, suppose rotations are two types in quantum mechanics: rotation in spin space, okay, rotation in orbital space, okay, rotation in spin space and rotation in orbital space. Suppose you have the Cartesian coordinate system like that, okay, x, y, z, okay, and here you have Cartesian coordinate system, and here a vector is making an angle. Let me change the pen color. A vector n cap is making an angle theta with respect to that Cartesian coordinate system. And suppose we know what? We know that S equals h cut by 2, S vector equals what? H cut by 2 sigma vector, okay. And S vector has, suppose, eigenvalue chi s. Eigenvector chi s. Now if we want to rotate it, this eigenvector about some system, about an angle theta, if we want to rotate this eigenvector, then we have to operate an unitary matrix. We have to operate to rotate chi s to another eigenvector chi s prime. We need an unitary operator. You can say unitary operator. U is unitary operator, or unitary matrix, you can say, unitary matrices. So in the operator form, unitary matrices is such that in the operator form you can say that unitary matrix, we can write chi x prime equals exponential plus minus iota alpha n dot is vector by h cut into chi s, okay. Yeah, and alpha is the angle. Now suppose here it is angle, by which angle you will rotate it. Now it has general format. Now S equals h cut by 2 sigma. Now it has general format, that is the rotation operator, that will be exponential plus minus iota sigma n alpha. or iota, sigma and theta, whatever you will write. Now what has the minus sign significance? Minus sign has significance, physical significance, that when you will rotate it clockwise, okay, when you will rotate it clockwise or left hand sense, then it will be minus. But when you will rotate it in positive, that means anti-clockwise sense, then it will be plus. Now return back to the question. In that question we have been given z plus, that is eigenvector z. It has its Cartesian form is 0, 0, 1. Similarly x plus has Cartesian form 1, 0, 0, okay, and y plus Cartesian form 0, 1, 0. But the eigenvector of z plus is what? Eigenvector of z plus is 1, 0. Eigenvector of z minus vector is 0, 1. Corresponding to eigenvalue plus h cut by 2, it has eigenvector 1, 0. Corresponding to minus h cut by 2, it has eigenvector 0, 1. Now operate that rotation operator. What was that rotation operator? Rotation operator that has been given in the question. There exponential minus iota sigma z pi by 2 into exponential iota sigma y pi by 4. Operate it on what? Operate it on 1, 0. Now we will do that operation from right hand side, from here. First it will operate on it, after that these will operate on it. So first exponential I sigma y, let's do the calculation. First exponential I sigma y pi by 4 whenever it is operating on 1, 0. Exponential plus I sigma y, exponential plus iota sigma y pi by 4 when it is operating on 1, 0. First calculation 1, step 1. So what is the formula? I cos theta plus iota sigma n sin theta. And sigma n is what? N is y. So I is identity matrix actually. Let me write clearly. Exponential plus iota sigma y pi by 4 when it is operating on 1, 0, then it will give I identity matrix cos pi by 4 plus I sin pi by 4 1, 0. Okay, now iota is identity matrix. So let's do the calculation. I cos pi by 4 plus iota sigma y pi by 4. So now I is what? 1, 0, 0, 1 identity matrix. Cos pi by 4 is what? 1 by root 2 plus iota sigma is what? 0 minus I 0. Okay, 0 minus I 0. So 0 minus I 0 whenever we will operate it on 1, 0. So it will give, now it will give something. So now just do the calculation. So after the calculation we will get, now after calculation, see, I is identity matrix 1, 0, 0, 1 multiplied by cos pi by 4. I identity matrix multiplied by cos pi by 4, that will give you what? Cos pi by 4 1 by root 2, 1 by root 2 into 1 by 0, 1, 0, 0, 1, 1 by root 2 0, 0, 1 by root 2. Okay, plus iota into sigma y. Sigma is what? 0 minus I 0. So iota into 0 minus iota into iota. So 0 minus iota square, that means minus iota square is plus 1 into iota means minus 1. Okay, 0 iota, sorry, here it will be plus, here it will be minus. Okay, iota square, that will be minus into 1 by root 2. Now take 1 by root 2 common from both matrix. 1 by root 2 after taking common from both matrix, we will get 1 1 minus 1 1 plus 1. So after first operation, we have still not operated this matrix on this kth vector 1 0. After operation 1 by root 2 1 1 minus 1 plus 1, this matrix we have not still operated. We will calculate second operator first, then we will calculate at last. Second operator is what? Exponential minus iota sigma z pi by 2. Do the same calculation in this way. After doing the same calculation, we will get I cos pi by 2. Cos pi by 2 is what? 0. Okay. Cos pi by 2 0 means what? Cos pi by 2 0 means identity matrix will get nullified. So identity matrix will be 0. Total identity matrix will be 0 minus iota. Here it will be sigma z minus iota sigma z sin pi by 2. So minus iota sigma z 1 0 0 0 minus 1 to sin pi by 2. Then it will, what we will get? We will get minus iota into 1 0 0 minus 1. So now if we write exponential see very concentratedly, exponential minus iota sigma z pi by 2 into exponential iota sigma y pi by 4 on 1 0. Okay, so what we have got from the calculation 2, that we have got minus iota 1 0 0 minus 1, this operator has given this, into what we have got from this 1 by root 2 1 1 minus 1 1 on 1 0. Okay, so now after the total matrix multiplication, first multiply these with this, then multiply these with this. After the total matrix multiplication, what you will get, that is, after the total matrix multiplication, you will get minus iota by root 2 1 1. If we see minus iota as a constant, if we take it as a constant, then it will be remaining in this form, 1 by root 2 1 1. So some constant into 1 by root 2 1 1. Now the thing is, what is this? This is the eigenvector of spin matrix S comma S x, x component of spin matrix. So this is eigenvector of x component of spin matrix for S equals half. That is, S equals half positive, means positive sense is what? 1 by root 2 1 1. So after operating that thing, what we are getting after operating on that rotation operator on that 1 0, that kth vector z plus, we have got x plus, means positive means positive x component I of eigenvector Sx, x plus. So that is the thing. In our next videos, we will discuss about rotation in orbital space. That is more simple from it. So that is it for today. Thank you so much for patiently watching this.